Let's talk about inverse Laplace transforms. Here's a problem we've seen before. Using Laplace transforms, solve the initial value problem. dy dt equals y minus 4e to the negative t, y of 0 equals 1. We started this problem, but we were unable to solve it. Here's where we ended up. Okay, we took the Laplace transform of each side, ended up with this. Okay, the left side turns out to be s y of s minus y of 0, and the right side is the Laplace transform of y minus 4e to the negative e to the t, or minus 4e to the negative t. And that turns out to be the Laplace transform of y minus 4 times the Laplace transform of e to the negative t. Okay, we use these formulas for the Laplace transforms of y, y prime, y double prime. And these Laplace transforms of y, t to the n, e to the at, t to the n, e to the at. And we'll just throw these in for fun. Sine, cosine, hyperbolic cosine, hyperbolic sine. Okay, so this was the left side, and this is the right side. So we're going to look at the inverse Laplace transforms and see how to solve this initial value problem. So what we end up with is, okay, so again, here's the problem we've got. We're going to get y of s all by itself. Well, first, let's replace y of 0 with 1, because we were told the initial value of y of 0 is 1. So we have sy of s minus 1 equals y of s minus 4 times 1 over s plus 1. Let's get the y of s's on the same side. So we'll move this y of s over here. We'll move the 1 to the other side. And we end up with this. Then let's factor out a y of s. We have y of s times s minus 1 equals 1 minus 4 times 1 over s plus 1. So if you divide both sides by s minus 1, you end up with y of s equals 1 over s minus 1 minus 4 times 1 over s plus 1 s minus 1. Ooh, look at that. These multiply together nicely. So when you multiply those together, you end up with 1 over s squared minus 1. So we have y of s equals 1 over s minus 1 minus 4 times 1 over s squared minus 1. Now we take the inverse Laplace transform of each side. Laplace transform of y of t is capital Y of s. So the inverse Laplace transform of y of s, capital Y of s, is just y of t. We're just reversing it. Okay, so this thing over here, this Laplace transform, that's just inverse Laplace transform of that. That's just going to be y of t. Okay, the inverse Laplace transform of 1 over s minus 1, let's see what that is. The Laplace transform of e to the at is 1 over s minus a. So the inverse Laplace transform of, we're going to plug in a equals 1. The inverse Laplace transform of 1 over s minus 1 is just plain e to the t. Okay, so Laplace transform, inverse Laplace transform of that is just going to be e to the t. Minus 4 times, okay, so we have minus 4 times the inverse Laplace transform of 1 over s squared minus 1. Well, the Laplace transform of sinh, kt, is k over s squared minus k squared. So you plug in k equals 1 and take the inverse of each side. You get the inverse Laplace transform of 1 over s squared minus 1 equals sinh t. So this ends up being, this factor, this just ends up being minus 4 sinh t. And that's our answer. Y of t equals e to the t minus 4 sinh t. Let's look at some inverse Laplace transforms, not in the context of a problem, but just so you know these things. How about the inverse Laplace transform of 1 over s to the fifth? Okay, we're going to use this formula for powers. The Laplace transform of t to the n equals this, because, look at this. This looks just like what we want. Okay, 1 over s to the fifth. So we're going to plug in, looks like we need to plug in n equals 4, because then the bottom would be s to the fifth. So we take the inverse Laplace transform of each side, inverse Laplace transform of n factorial over s to the n plus 1 is t to the n, plug in n equals 4, and we get the inverse Laplace transform of 4 factorial over s to the 4 plus 1. In other words, the inverse Laplace transform of 24 over s to the fifth, that equals t to the fourth. So pull the 24 outside, and we end up with this. And then divide both sides by 24, and we end up with the inverse Laplace transform of 1 over s to the fifth is t to the fourth over 24. How about this one? I should have labeled this one b. Sorry about that. The inverse Laplace transform, it's not too late to call this b. Sorry about that, folks. How about the inverse Laplace transform of s plus 3 squared over s to the fifth? Okay, so what we'll do is break this up. Multiply it out, we get s squared plus 6x plus 6s plus 9. And then break up those fractions. We have s to the fifth s squared over s to the fifth, 6s over s to the fifth, 9 over s to the fifth. These simplify to the inverse Laplace transform of 1 over s cubed plus 6 over s to the fourth plus 9 over s to the fifth. In other words, it's the inverse Laplace transform of 1 over s cubed plus 6 times the inverse Laplace transform of 1 over s to the fourth plus 9 times the inverse Laplace transform of 1 over s to the fifth. So we're going to use that same formula to evaluate these. So first, we need to figure out the inverse Laplace transform of 1 over s cubed. Okay, here's the formula we're going to use. Take the inverse Laplace transform of both sides. We end up with this. Okay, so notice, if we're going to apply this formula, n needs to be 2, because this is going to be s cubed. So plug in 2, we get the inverse Laplace transform of 2 over s to the 2 plus 1, which is the inverse Laplace transform of 2 over s cubed. In other words, it's 2 times the inverse Laplace transform of 1 over s cubed. That's t squared, because again, n equals 2. Divide both sides by 2, and we end up with the inverse Laplace transform of 1 over s cubed equals t squared over 2. In the same fashion, we need to find the inverse Laplace transform of 1 over s to the fourth. So we're going to plug n equals 3 into this formula, because then this denominator is going to be s to the fourth. So we have 3 factorial over s to the 3 plus 1. In other words, the inverse Laplace transform of 6 over s to the fourth. That's 6 times the inverse Laplace transform of 1 over s to the fourth. That's t cubed. Divide both sides by 4, and we get the inverse Laplace transform of 1 over s to the fourth, which is t cubed over 6. Okay, so now we plug everything in. So this was the equation we had. 1 over s cubed, the inverse Laplace transform of 1 over s cubed is t squared over 2. Inverse Laplace transform of 1 over s to the fourth is t cubed over 6. Inverse Laplace transform of 1 over s to the fifth, that's t to the fourth over 24. So when you simplify this, the 6's cancel, the 9 and the 24 cancel partially, and we're left with t squared over 2 plus t cubed plus 3t to the fourth over 8. Using Laplace transforms, solve this initial value problem. dy dt plus 2y equals e to the 4t. Y of 0 equals 6. Let's do another one, because you need the practice. So we take the Laplace transform of both sides. We end up with this. Laplace transform of dy dt is going to be this stuff over here. We've seen that before. Laplace transform of y, that's just plain y, capital Y of s. And we've seen that this is the Laplace transform of e to the 4t, because the Laplace transform of e to the at is 1 over s minus a. Here a would be 4. Okay, we're going to get the, so we replace y of 0 with 6, because we were told that y of 0 equals 6 up here. And we end up with this equation. So now let's get the y of s's on the one side and move the 6 to the other side. And this is what we end up with. Let's factor out a y of s. Get y of s times s plus 2 equals 6 plus 1 over s minus 4. Divide both sides by s plus 2. And we end up with this. Now we're going to use partial fractions. Remember that from Calculus 2. Partial fractions. It rears its ugly head. So 1 over s minus 4s plus 2 can be rewritten as a over s minus 4 plus b over s plus 2. Multiply both sides by s minus 4s plus 2, the denominator, and this is what we end up with. And now we find the values of a and b that will work. These should work for all values of s. Let's plug in strategic values of s, like s equals negative 2. I picked that one because then this factor is going to be 0. So we have 1 equals a times 0 plus b times negative 2 minus 4. In other words, 1 equals b times negative 6, so b equals negative 1/6. In the same way, we're going to plug in s equals 4, so that this thing can be 0. So we have 1 equals a times 6 plus b times 0. 1 equals 6a, so a equals a sixth. Okay, so this is what we end up with. We can rewrite 1 over s minus 4s plus 2 in this fashion, and so we do. So we have y of s equals 6 over s plus 2, plus, again, this is what we had earlier, but oh man, we can introduce the new and improved version of that statement. Notice that this is a 6 over s plus 2, this is a minus a sixth over s plus 2. We can combine those and just get 35 over 6, s plus 2 over here, and the 1/6 s minus 4 that just carries over. So now we just take the inverse Laplace transform of each side. Inverse Laplace transform of y of s, we know what that's going to be. That's just going to be y. Okay, that's just y of t. That's going to be the inverse Laplace transform of 1/6 over s minus 4 plus 35/6 s plus 2. That's why we broke it up using partial fractions, because we can easily calculate the inverse Laplace transform of these. Inverse Laplace transform of this guy is either 4t, and inverse Laplace transform of this guy is either negative 2t. So here's our answer. Y equals 1/6 e to the 4t plus 35/6 e to the negative 2t. And we've done it.